Okay, so we're all going to do question 9. If you did not draw hockey players, I want you to please try to draw them. I'm going to try and draw them. Okay, here's hockey player A. Okay, there's the hockey stick with the hockey puck. I need everyone to participate, please, including you. Okay, so he has the hockey puck, mass of 90 kilograms, initial velocity of 5.0 meters per second. Now, only like one of you in here got this numerically right, so we all need to do this. Okay, hockey player B is skating towards hockey player A. Okay. Mass of this hockey player is 110 kilograms. Initial velocity of 3.0 meters per second. Okay, now since they're skating, do they have kinetic energy? Yes. We're going to calculate the initial kinetic energy of each. So this is 1/2 mv squared. So this would be 1/2 90 kilograms. Okay, times 5.0 meters per second, and square the velocity. So the kinetic energy of this hockey player A would be 1125 joules. Okay? So the kinetic energy of this hockey player over here, kinetic energy initial B, again, 1/2 mv squared. So that's 1/2 110 kilograms times 3 meters per second, and square the velocity. So that kinetic energy is 495 joules. Okay. Before they hit, we want to know how much total kinetic energy, if you put them together, before they hit, what would they have? So the kinetic energy before is not going to equal the kinetic energy after. Now, why is this? Because when they hit, this is not going to be perfectly inelastic. This is just going to be an inelastic collision. Now, is kinetic energy conserved in a collision, yes or no? No, it is not. Okay? In a pretend fictional environment, it's conserved if it bounces off. In a frictionless pretend environment. But this is not that. This is sticking together. Right? So the before kinetic energy is not going to equal the after energy. So how are we going to get the before energy? We're going to add these two. So right now I want you to add 1125 and 495. If we add those two guys together, the kinetic energy before is 1620 joules, right? If you put those two together, you understand that, you? Do you?
Yes.
Okay. So now we're going to do after. So let's make a big pile here. Whap. All right. They hit each other. Pow. All right. There's a stick flying over here. There's a stick flying over here. Got arms here. Arms and legs there. Okay. Arms this way. Arms this way. Feet. Okay. Feet. 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 Okay. Pow. Okay, so what happens? They stick together. This is an inelastic collision. So now what do you have to do to the masses? You have to add them. The mass of A plus the mass of B, all right, and a final velocity squared. Now, some of you calculated the final velocity. It didn't ask you to do that. It gave you the final velocity. The final velocity was 1 meters per second squared, and you add the two masses. So that's 90 plus 110, that's 200 kilograms times 1/2. So the kinetic energy after is how much? Go ahead and calculate that. 1/2 times 200 times 1 squared. Well, that's 200 times 1/2. That's just 100, isn't it? Okay, so it's 100 joules after. So it's 100 joules after. So obviously these are not equal to each other. So how are we going to find out how much is lost?
The 1,620 minus the 100.
That's right. We're going to subtract. So we lost kinetic energy. So it's 1620 joules minus 100 joules. And the answer is 1,520 joules were lost. Now, how were they lost? What was the form of heat and sound. Okay? Heat and sound. So they went whap. Okay, also it was lost when hockey sticks and equipment started flying everywhere. Okay? Also it was lost in the deformation of the hockey equipment, like the helmets went when they squeezed together. And maybe their faces smashed together, or maybe they lost teeth. Okay? If you're out there on the soccer field, you don't have any helmets on, and you guys both go for a header, and instead of hitting the ball, you hit heads. Okay? Would that be an inelastic collision? Yes, it would probably be. Okay? It would probably be a partially elastic collision. But what would happen? Yeah, your energy would get absorbed by your necks, and you'd have split heads, and you'd have missing teeth, right?
Well, I mean, the worst I've ever seen is a dislocated jaw and a broken knee.
Well, there you go. So that's where the energy went into. Okay, so the before kinetic energy does not equal the after energy. So in order to find out how much you lost, you need to subtract. And it got converted to heat and sound and deformation of the materials. Okay?